Chapter 6, Section 3, Question 1 and 2. We're going to be simplifying complex fractions. You'll remember from Chapter 1 that complex fractions are fractions inside of fractions or decimals inside of fractions. Obviously, here we have fractions inside of fractions. We're going to make a common denominator just for the numerator, which would have a b in the denominator. This one already has it. This one needs it. We need a common denominator in the denominator. This has a 3. So this one will need a 3 on the numerator and the denominator. Remember that we always want to make everything over a common denominator. So here, the numerator is going to be 3b. You could write b3, but normally we write the coefficient, the number in front first, and the variable second, minus a, all over our common denominator, which is b. We have our really large vinculum separating the numerator fraction from the denominator fraction. In the denominator, we'll have 3b minus a. Notice that by writing 3b minus a and 3b minus a, those are going to be canceling, and our common denominator is 3. We also learned about copy dot flip, or multiplying by the reciprocal. So this first one is going to get copied. The second one is the one that's going to get flipped. That is your reciprocal. It might be useful to put these parentheses to make sure that you are canceling out this entire set with this entire set, so you're not accidentally reducing here or not accidentally reducing here. All that's left is 3 on the numerator and b in the denominator. That is very simplified. Chapter 6, Section 3, Questions 1 and 2, Type 2 of 2. All right, we still need to make the common denominator for our complex fractions. So here, this has xy and this only has y. We need to multiply it by x. This one has an x. We need to multiply this one top and bottom by x. This is why we started off teaching you like this in Chapter 2. So from here, we want to make a single fraction. X times x gives us x squared minus 1. You might see that that is a difference of squares. Our big vinculum for the middle, notice that this is significantly longer than those. And here we have xy plus y over x. And you might see that there's a common factor there. Multiplying by the reciprocal, multiplying by the reciprocal, we're going to reciprocal that. I believe this is where the half credit lies. We're going to factor, cancel, write a better answer. Our difference of squares, again, if you write x minus 1 and x plus 1 instead of x plus 1, x minus 1, that is fine. Here we have our greatest common factor. And we're going to look, x plus 1 on the top and on the bottom. X minus 1, plain x, and that's it. So x minus 1 over y. Chapter 6, Section 3, Question 3. We're still simplifying complex fractions, and you might look and say, we don't actually have complex fractions. We don't have fractions inside of fractions. But if you remember from Chapter 1, we have negative exponents. If this was being multiplied, you could take this a and put it on the bottom and this b and put it on the top. But we can't. From Chapter 1, this is equal to 1 over a. This is equal to 1 over a. B to the negative 1 is equal to 1 over b. Because of the adding and subtracting, all they can do is flip to the bottom of its own little term. A, b to the negative 2. The negative only applies to what is right in front of it, so the a would stay on the top, and the b squared would go to the bottom. And a to the negative 1 gives us 1 over a. We again need to make common denominators, so we're multiplying this by b and this one by a's. Remember to put them on top and bottom. Some students say, hey, I understand it, but then what it says is incorrect. We want to make our middle vinculum very long to make sure that we can see the difference from the numerator and the denominator. And we want to make one fraction out of this. Then we want to copy dot flip. There are a couple things here that are a little tricky. You'll notice that this is written backwards. Normally we write it with A's before B's, with A's before B's. Let's take a look at this. We have B minus A. If I were to write it with A's first and B's second, there's a leading negative, so I want to factor out that leading negative. So this is going to factor as negative, parentheses A minus B. Here, many students try and take out an A and a B because they see the A and the B, and they really want to cancel it. What I want you to remember is, how do you factor x squared minus 9? That would factor as x plus 3, x minus 3. This is a difference of perfect squares. This is a difference of squares as well. So it will actually factor as a plus b and a minus b. This is one of the most common mistakes, and this trick here is often seen up to 4 times on the test, which will take you down without a letter grade. We don't want that. All right, so here, the negative, there's no negative in the denominator, and a minus b will cancel out with an a minus b. The a all by itself will cancel out with the a all by itself, and one of these b's will cancel out with a single b there. Be very careful. There's a negative and a b that did not get canceled out. And on the denominator, we have an a plus b. Notice that since this is the only binomial in the denominator, I no longer need the parentheses. Down the first column, coming up, and then down the second column to the answer. Chapter 6, Section 3, Question 4. This is one of the only sections that doesn't have a Section 5 in it, or Question 5 in it. So here, remember from a long time ago that area equals length times width. That is a script L. It says to find the missing length. So from chapter 2, to solve for the length, we're going to divide both sides by the width. We'd like the single variable to be on the left-hand side. So the length is equal to the area divided by the width. This is the area, which is on the inside. We want to take this and divide it by the width. You'll notice that that actually looks almost exactly like something from back in 6.1. To divide fractions, we're going to copy dot flip. We're going to take this times this. And then we're going to factor cancel and write a better answer. Notice that I put parentheses on that to make sure that that cancels out correctly with other binomials, like that one. Don't start canceling it out yet, because you'll get distracted and make mistakes. This is where half credit is. If you factor everything correctly, that's half credit. Make sure that you don't cross them out in such a way that I can no longer read it. There's an x plus 7 in the numerator. There's an x plus 3 in the numerator and denominator. There's an x plus 5 in the numerator and denominator. and that's it. So we have x plus 7, x minus 3, and x plus 1. I don't actually need the parentheses in the denominator. It doesn't matter if you have them. And we're solving for the length, so this is the length. And because this is a picture problem, we're going to need to label it with units. Remember, if it was an area, it would be units squared, a volume would get units cubed, and everything else gets units regular. Unless it actually states a unit, in which case, then you would have to use the units that were given. Some students are asking about this. Why does it say x is greater than 3, and what do you do with it? For most of you, you're going to do absolutely nothing. But if x is greater than 3, then this is a positive term, and the rest of them will also be positive terms. That's why it's there, is to make sure that all the lengths and widths are all positive.